Hallo und herzlich willkommen zur 30. Folge des All-Day Research Podcast, der euch dabei helfen soll, schnell und effizient in die Welt der Forschung einzusteigen. In der heutigen Ausgabe begrüßen wir Prof. Dr. Habernal. Gemeinsam mit unserem Moderator Marvin Beckmann spricht er über Natural Language Processing. All-Day Research Podcast.
Welcome to the next episode of the All-Day Research Podcast. My name is Marvin Beckmann, and today's topic is about natural language processing and its applications in understanding the law. And therefore I talk with Professor Dr. Habernal. Nice to have you.
Hey, good morning, everybody. Happy to be here.
We usually start by introducing our guests. Where do you come from? Where did you study? And what were your stages such that you ended up in Paderborn?
So this is the trickiest and the longest question I can answer, and I don't want to spend an hour explaining my curriculum vitae. But I originally come from the Czech Republic, which is the next country on the east from Germany. I studied there in the beautiful city of Pilsen, which some people might know not because of the science, unfortunately, but because of the beer. You know, the Pilsner Urquell coming out of there. I'm not super proud of this, but that's how it is. So I studied there, did my master's, and did my PhD as well with these beautiful people at the University of West Bohemia in the area of natural language processing. And then through various ways of stages of life and doing different also jobs and being in different roles, such as doing music more, playing a lot of music actually, and then studying music also parallel to doing PhD in computer science. I ended up 10 years later in Germany, or basically in Paderborn, taking a professorship for natural language processing this semester, and I'm super excited about this new role here. So this is long story short. I did study computer science. I did study NLP, and also did study a little bit of music, and did many things in between.
Before I'm not able to ask the question later on, what kind of instruments do you play?
I play the bass, both the electric bass and the acoustic bass, like the contrabass thing, But I started as a piano player. So at the school, I learned how to play piano. And also I played one gig as a drummer, just for fun. I thought like it must be easy to play drums, right? So I bought drums and played a gig as a drummer, but it was horrible. So I quit that. I'm not a drummer, but I played a bass. Yeah.
Okay. Natural language processing as a field has grown over the past years, at least from my personal perspective, my personal view. How did you come in contact with it the first time? So the world has changed in NLP quite a lot, significantly. And like 10 or 15 years back, when I was finishing my master's and started my PhD, it was really different world. And NLP was a little bit of a niche in the research where, you know, we were working on statistical NLP, doing language models or trying to understand semantics. And we had all these. Semantics means like the meaning of the words or meaning of sentences, and there was a lot of influence from, I would say, from linguistics, how to model meaning of things, and then it came like the big wave of deep learning, 2010 and 2011, 12, where it became very apparent that the statistical way of modeling language and having a lot of data to train some models is the way to move forward. So the landscape has shifted. But when I started, we are working on trying to understand a meaning of a sentence, which nowadays seems to be a little bit solved to some extent, depending on the task. Yeah. So you'd say your field has dramatically, in some sense, changed.
Oh my, yeah, the field is completely, it's completely redone. I mean, we had to redo everything where nothing was set in stone, and basically, with these, it's called a deep learning wave. So the deep learning is basically using, deep neural networks, which have large number of so-called parameters. So it's a sort of a big program trained on big data sets. And before that, if you need to solve a task, you would kind of need to understand the task. So let me give an example. If you want to
say whether a review on Facebook about a company is positive or negative, which is called a sentiment analysis. So some people might be familiar with this term. And you want to say whether a piece of text about a product or a hotel is positive or negative, you would have to kind of look at the actual words and maybe extract some sort of so-called features from these words and build them together and try to learn something. And nowadays, you just don't think in this low-level terms. You just use so-called pre-trained models or even like ChatGPT, and it's a solved problem now. So it really has changed drastically.
In your field, are you able, when you, in some sense, build a model, to understand why your model behaves the way it does? For example, sometimes, or a big part of machine learning is also understanding what your model does, what your system does, and also why it makes certain decisions. Is this possible in natural language processing in a better way?
So in natural language processing, there is it has a very nice feature, so to say, in the whole field, because you as a human, if you read your input data is a text. So you as a human really understand what's coming in. So for example, the hotel reviews we're talking about. So you can read a hotel review, and if it says something, oh, it was really horrible here, then you understand the meaning of that. While in contrast to some, let's say if you would be processing some signal data, so something from like a machine or satellite signals or something like that, you don't understand it as a human. So we kind of tend to think, well, we should understand the input and we should be able to understand the predictions of the model as well, because, we are humans, we can work with text. And if you tell me a word horrible, I understand the meaning of that immediately. So I believe we're kind of biased to tend to expect too much from these models. And let's put it like that. I mean, if you have sort of model, and we didn't talk about what the models are, basically the models are functions. So you need to transfer the input text into numbers, basically. And there's different ways of doing so. But what you're doing is you're putting numbers into a function, and the function creates some other numbers out of it. And you can then change the output numbers into words again. For example, if you want to, translate the text using Google Translate. It's basically words in, words out. But the internal workings of these models is a function transformation of numbers by using some functions, and it's mostly deterministic. I mean, there's some randomness involved in generating the output, so you might want to maybe not always generate the same next word, so to say. But most of this working is very deterministic, and it's basically a function. And nothing is preventing you to understand a function. I mean, if you as a mathematician look at a function, you know exactly what comes in and what comes out. So this is very transparent. So people are talking about black box deep learning and not being to understand it. So it's just a matter of describing what understanding means. So if you can understand it very clearly, so you see numbers coming in and numbers coming out. The functions are though very complicated and very large. So you will be very hard time to grasp the meaning of these functions. So that's why maybe you don't understand how it works, because it's just too big. So all the functions, if you're talking about ChatGPT, which many people know, it's a huge function, and it has very, very many million tiny little functions in there. And of course, you can't even read a function. I mean, it's maybe too big even to read. So you don't understand it in a way as a human intuition, but it's possible to understand it. So what the community is trying to do in the direction of, explainable AI is the direction to find sort of proxies, so some simplification of these things to see, if I put these numbers in this hotel review and it's coming out saying negative, what happened not on the very tiny detailed level, but in general? Are there patterns in the machine that kind of tend to predict these things? So this is it. This is what we're trying to make it understandable for humans. So basically, this is understandable. You can explain it, but it makes no sense for a human in the first place.
Okay. Each guest is asked some either-or questions. Just
either-or? Oh, okay, wow.
Just from the top of your head, answer with your first thought or what you prefer. Beer or wine?
Well, none. Okay, but I would say beers, because I have to be proud of where I come from. So maybe beer.
Mountains or sea?
Mountains or sea? Mountains, absolutely.
Hardware or software?
I have no clue about hardware. I guess software, yeah.
Theory or practice?
Theory or practice? Wow. It's a tie. I'm sorry, it's a tie.
Data in the cloud or on your own hard drive?
Since I work in privacy, I have to say maybe on your own hardware is better, but cloud is just very convenient, yeah.
I guess for the next question, you probably had to have been to the campus. If not, you can just say no. Mensa Forum or Mensa Academica? So either the top Mensa or the lower Mensa on campus.
Oh, okay. I haven't tried either of those because I'm in the Fürstenallee, which has a beautiful Mensa. Objectively and subjectively, it's really tasty. I cannot tell. I'm really curious to find out.
Coffee or tea?
Coffee, yeah.
And finally, written or oral exam?
Oh, absolutely written exams, yeah, because oral exams are just so subjective and biased, and yeah, written, absolutely.
Thanks. How do you define your own field of research?
How do I define my own field of research? So we are, in your introduction, you said we are working in the area of NLP in some subfields, and one of them is working with legal text or legal domain. So this is how we define. Means I would define it like whatever is somehow related to the legal praxis or legal theory that we are trying to be active, and we're growing in there. So this is one of the definition of the field. So it's more this interdisciplinary because we need a lawyer. I mean, I'm not a lawyer. Students in my lab are also not lawyers, but they do understand maybe a bit more law than I do. But we have partners here in the law research that kind of are the experts in their domains and help us to do this interdisciplinary research. So this is one definition of that. And the other area we are active in is this privacy in natural language processing. So what I mean by privacy is if you would be part of for example, of the training data, and maybe you are part of the training data without knowing that. So maybe your personal data, your preferences. I mean, maybe my personal data after this interview will also be part of training data of the next generation GPT, and the GPT will know that, this guy prefers, beer over wine. And maybe it's a private information. Well, it's not private anymore because we're talking about it, but maybe it's something I don't want the models to remember or even spit out. And that's exactly what you're trying to do. So if you're part of the training data, the model can remember more about you than you really want. And we're trying to find ways how to stop that, how to prevent your privacy, at the same time having the utility of these models. So doing these translations or text generation and stuff like that. So this is an area of, we call it privacy preserving NLP. And the definition is just giving examples like, well, will you give me your data if I promise you some sort of privacy, and to which, for which price? So there's always a trade-off between everybody's privacy and the utility we're getting. But the point is, so far it hasn't been a big issue because the whole community, NLP and maybe machine learning and AI in general, they just try to build the best models to score the best on the various tasks, but not really being fair or being privacy preserving and stuff like that. So it's sort of like a technical debt or research debt, which we're trying to tackle to do it, to have the means to do so if we really need to.
I looked through your publications, and I think this is also can be found in your research, because if I understood your paper, one of your papers correctly, you found an autoencoder that, although should be somewhat private, wasn't differential private?
Oh, you're using really jargon here. Okay, so we can go deep. Yes, we can go really deep. So you mentioned this differential private thing. So differential privacy it comes from, I guess, from the community of cryptography and security on databases, I guess, secure or private analysis of tables. And the idea of differential privacy, which is nowadays I would call like a de facto standard for doing things with data where privacy is an issue. So what they're saying is that if your data is part of the model, for example, or of the analysis, then the difference, if you are in there or not in there, the influence on the output of the model will be negligible, will be very small. So if I'm going to ask you, well, will you? So, dear Marvin, please give me your data, which is I don't know, like 50 last messages on WhatsApp. And if I promise you, if you don't give me the data, or if you give me the data, the difference will be very small. So your privacy will be somehow protected. That's exactly what differential privacy is offering you. So some sort of deniability. You can always say, well, I was part of the data, or I wasn't part of the data, and there are some probabilities. So this is very technical and formal thing. And since this is formal, you can really prove that whatever you're building, that your algorithm, your model is sort of differential private, so to say. So there are some of these formal guarantees, and if you promise these guarantees and don't screw up the implementation, everything should be safe. And what we've observed within my group is that it's actually pretty hard to do it right. So it's similar to if you have security protocols. So it should be, everything in security should be as public as possible. There is no security through obscurity. This is the term they're using. You should always reveal everything you have to make it transparent and for other people to find bugs, because if you have a bug in your security protocol, that's a bad thing. The protocol is designed to be safe by design. The protocol should be safe by design. Excuse me. And you need transparency and sort of reproducibility in there to make sure that it really does what the promises are. The same is in this privacy field. So again, there's some formal guarantees you're getting from the algorithm, but the devil is in the detail. And if you might be doing wrong the implementation, which is surprisingly, it happens very often, unfortunately, or even the formal proof might be wrong, and then you might claim I'm giving you privacy, but in the reality it's not the case. And it happened in, maybe you're referring to one of those papers where some group of researchers proposed a algorithm and saying, okay, this is now differential private, which means if you give me your data, I will protect your privacy. And the results just were too good to be true. And it was unfortunately the case. So if you dig deeper into the details, we were able to find so sort of a bug. It was a bug in the proof, I guess. So it was one of the theoretical, but it happens also practically in the code. Sometimes there's bugs, and once you have this transparency, you can really kind of find these bugs and make sure that everything is as you promise. So this is one of the challenges of the field, not challenges of the field, but what we're aiming for in the research is really being as transparent as possible and really put everything out there, like all the source codes on the GitHub, and everybody can basically double check to really make sure that what you're promising is correct.
Is it hard to achieve this kind of privacy?
So what is hard? That's a good question. What is hard?
Is it for someone who is not that familiar in the field possible to design an algorithm that fulfills this privacy promises?
I guess it really depends on where you're coming from, what's your background. So my background was NLP and machine learning a little bit in there, and a lot of data analysis and crowdsourcing and all the things. So coming to this field of theoretical computer science where you have proofs in papers. I mean, when I saw the first paper with a proof in there, I was just trying to cry, and I was just like, I don't want to do this. I mean, I was good at math, but it's been a while. So it needs really like bridging a field of sort of theoretical computer science, maybe a little bit of statistics and formal proofs, like really mathematical background with the actual implementation and with actual data set, manipulation and stuff like that. So it might be hard for some people. It might be super easy for other people. I cannot really judge. But there is a gap between these two fields, like one of them being the hardcore, so to say, differential privacy, which is some sort of, it's a branch of statistics and mathematics, maybe I would say. And these people have different language also. When they talk about things, they really talk about, they're using the language which people from other fields, such as NLP, might not understand, and vice versa. So we're trying to bridge this gap and, for example, provide for the NLP community. So this is where I live, where I'm home. and my research group as well, we're trying to educate as well. So, for example, giving tutorials on differential privacy and NLP in the NLP community. So that people understand the trickiness of that.
You already mentioned that your kind of progress started really in the field of NLP. How did your own research change in your recent years?
How did my own research change in the recent years?
As I looked over your papers, you basically started with a lot of argumentation mining.
Yeah, that's true. Okay, yes.
Yeah, and in the recent times, you looked into a bit other stuff. Just put it at stuff.
Yeah.
For now, but how did this kind of change came from? Where did this
why I change focus and do something else now instead of staying in the argument mining field? That's what you're trying to ask. Well, exactly. Yeah, I mean, people's priorities change for different reasons. Could be internal reasons, like you find a field not interesting anymore, or you don't have enough. Maybe you don't have enough ideas. You run out of ideas, and it's like, well, maybe this area is not for me anymore. It wasn't the case, actually. I mean, argument. So as you said, like we did quite substantial work in the area of so-called argument mining, which means I put it always like, trying to understand why people argue so badly on the internet. So,
nice
and
way to put it.
No, it's true. I mean, if you work with real data, real arguments on the internet, that's going to be very nasty. So, and usually these arguments, whatever, arguing about stuff is kind of taking very personally, and people commit all these fallacies. And that's why we did also like research on the fallacies as well to understand, how they work and is there a taxonomy. Anyway, so this was interesting, but then, priorities changed and you see like new research opportunities, and it could be also external factors, because when I started my independent research group before joining Paderborn, I was at TU Darmstadt starting our independent research group, and we also want to be somehow unique in the areas and also collaborate with people who had interest in collaboration with us, be it like this legal NLP stuff or be it the privacy stuff, which is somehow new. And if you see like research opportunity and you can relate to that and see, okay, I can imagine this field will grow somehow and it will be more important maybe in the future, then it also makes sense strategically to go there. So there's various factors, so internal and external.
With your legal NLP stuff, just to say it again, what is your kind of goal? What would be like, I have achieved this, now I'm very happy?
Oh, okay. I don't think there's I don't really think there's an end goal in research, so to say, because if there's an end goal, you work towards the goal and then it's finished, and then what? So every milestone in between which you achieve will just brings you more open questions. This is awesome about research. Like the deeper or the broader you go, but the farther you go to the next sort of thing that you think like, oh, when I do this, then it's finished and we're happy. You end up with more questions than you started with. And this is great. So research is never a linear thing. It's never linear. I mean, you might have a great plan to achieve the next milestone, not like the final goal. The final goal is, 10 years from now. And you can imagine like, self-driving cars and flying cars and stuff like that. And it won't be that. Like it will be something completely different. But the progress, going there and having these tiny little milestones and tiny little research questions is interesting, because the plan A never works, and most of the time like plan B and plan C never work as well, because the reality is just much more messier than you might think, and then you end up with plan C, which brings you like tons of other ideas in somewhere. So I mean I do have some personal vision where I would love to the world to be in is, for example, in this legal domain. Well, I would love to have a legal assistant that I can really ask legal questions in German, and then the assistant will give me the answers, which I would understand, not, what the lawyers are kind of saying. I don't understand a word in legal jargon, because nobody does understand except for lawyers. I really need something, that will help me to guide it, and also that I can rely on and I can trust. Because if I get I don't know, if somebody will sue me for some reasons, I don't know. I'm not expecting that, but just, hypothetically, if somebody, want to put you on the court, the only chance you have is just to pay for a lawyer and, or get some legal advice. While I believe everybody should have access to law for free, like we're living in a democratic country and we should be able to do that. But the burden is so big, and the gap between, even like the language gap is big. And even for me, like, second language speaker in German, I mean, I can speak German, but if I get a like official letter, I just really want to cry because I don't understand a word. And I think it's very, maybe like a native Germans. Yeah. Maybe native
Even for native Germans.
Exactly. Yeah. They say the same. That's, your case. So, so there might be ways. So this is like what I'm kind of not aiming as a researcher, but I can understand, I can imagine like this would be a future where we might have solutions, because nothing is, there's nothing blocking us maybe theoretically to go there, but practically it's a long way to go. But the rest is just, I would love to have tools that, from the privacy perspective, I would have loved tools where I can really share my data for, without the hassle of protecting privacy or GDPR and stuff like that. If I have a tool that does everything just, with a magic stick, and I can use the data freely and at the same time protecting privacy of other people, all the people in the data set, for doing some meaningful research, that would be great, but we're not there yet.
If you say you're currently working together with lawyers to hopefully work towards such a milestone, where are you currently at?
Okay, so I would say we're at the beginning. Well, it depends. I mean, we have some. So the collaborations with legal researchers there are several ones, and one of them is an ongoing project funded by DFG, by the German research agency, where we have some fundamental steps already done. And in this research, we are not focusing on this milestone of understanding the legal jargon and the position of the layman people, but it goes more to a fundamental understanding how the arguments in courts work. So in particular, we took this, there's this, the highest instance in Europe is the European Court of Human Rights, which means if you, for example, if you have a case against the country, so Marvin versus Germany, and you
Sounds very realistic.
Also very realistic, exactly. Well, you never know. Okay. Well, anyway, if this might be the case, and you have you feel like after all the trials here in Germany, you end up in Karlsruhe, and still you feel like your human rights were kind of violated, then you can go to this European Court of Human Rights, where it will settle the matter in terms of assuming, or in terms of deciding on whether your human rights were violated or not. For example, your right to privacy, or the right of for fair trial, and other articles from the Convention of Human Rights in Europe. So this is the last instance, so to say, which means this court and the court's decision are very important for the legal landscape. So if you were a legal scholar or legal researcher in this area, in criminal law or civil law, you would basically study these decisions and understand how the European Court of Human Rights decided in these cases, because they're not binding for the states, but they're highly influential. I mean, we're in a civil law system where the laws are, and their interpretation are the sort of gold truth, but we are using precedent as well as just a matter of stronger arguments. So if the European Court of Human Rights decide on something, then you should know it for your legal expertise and so on. But unfortunately, understanding these arguments in these decisions of this court is hard, because it's just there's too many. There's 100,000 or more than 100,000 decisions in there in French and English, and it's a lot of text, so nobody will be able to read it and understand, for example, which arguments were used for deciding these cases for various articles of the convention. So we try to build machine learning or NLP systems which can find automatically several patterns or several variants of argumentation in these court cases. And this is an ongoing research. We publish a data set about it and build models which everybody can download from GitHub and run and do their analysis. So this was the first step. Now we are actually looking into what happened before the final decision in this court, because some of these cases are discussed publicly. So there is this oral hearing where, the big chamber of the court or some other chambers get together. There's several judges sitting in there and both parties. So it would be like, Marvin, you would go to Strasbourg, and some from the German state would go there, and you would basically argue or put your arguments in front of the court for your case, and the judges would ask you and question you on some matter. So, and this is where actually the fun starts, because this has never been analyzed. So nobody was able to look into these oral hearings, because they're just sitting somewhere on the servers. I mean, you can access them. You can watch the videos. Actually, it's like video footage. You can watch it, but you have no transcripts. You don't know who is speaking when, and you have no tools of empirical analysis on that. And so we put another sort of landmark data set in here and try to semi-automatically transcribe these videos into text and align with speakers, make sure that we know who is speaking when in which language, because the European Court of Human Rights, it's a very multilingual. Like, the official languages are French and English, but what happens, you can either you can speak up in your mother tongue. So if you were from let's say Italy, you can speak Italian, and there will be live interpreted. So, or people are speaking in English, but it's their like second language. So if you use out of box speech recognition, even like the best ones, it's really hard to get it right. All the maybe names and the legal jargon and so on. So we made a fundamental sort of data set work in the last year, and just submitted this paper just today to a journal, AI and Law. So this is what we're doing, and there's a long way to go, because this is like fundamental work, where we really need the legal expertise, because they are asking their questions like, oh, so we don't know why the case was decided. So, but maybe some arguments from the hearing actually ended up in the judgment, and maybe some not. So what's going on there? All these questions, but you cannot answer them without having any data to start with.
How do you circumvent the language barrier? Do you use the kind of interpretations given live, or?
No, we use the original language. So you can access the original language, and you have currently you can use like multilingual models for speech recognition. So that's what we used. And we employed, we had a lot of student research assistants for basically manually correcting some parts of this data set. So make sure that all the names are correct and everything, basically double checking the quality of the data to make sure that the analysis down the road will be correct as well. So a lot of manual work, unfortunately.
At the start, we talked little bit about explainability, also explainability of language models, and it's quite native if you have something like an argumentation. Now, in your setting of law, you cannot, at least you as a researcher probably cannot distinguish whether your model performed good. How difficult is it to then include lawyers or someone who can judge the kind of quality of the output, who is not really actually familiar with natural language models themselves? Is this kind of a difficulty, or is this very homogeneous and works together very well?
Well, the difficulty comes in, so that's a great question, because exactly what you want to know. So what you really want to know is maybe not explaining every decision of your model, but having a look into where the model makes an error. So if your model errors on one particular example, and maybe there's a reason why it made an error. And for that, the expertise, like we call it very fancy word, error analysis, which basically means, using your eyes to look into the example and the error the model made, and trying to use your intuition sort of, or your expertise to find out, is there a pattern here? Is it something like why it went wrong here? And we did this actually with the legal experts. So we had for this project with the European Court of Human Rights, we had, I guess, 2 postdocs in law and 6 other student research assistants for a year. So really a lot of manual work. And they actually helped us also to do this error analysis of these predictions. And some interesting patterns, showed up here. And, I cannot really interpret what these patterns were, but they kind of find something for them as well, saying, oh, maybe we had maybe 2 different categories which were manually kind of distinguishing, and for us they were really 2 different categories in theory, but in practice, if I look at the output of the model and the model basically mixes up these 2 categories together, it actually makes sense because these 2 categories are actually one category. So maybe, we shouldn't, in theory, we should update the theory, so to say, and don't distinguish these 2, because in reality, they're just the same, and it makes no sense to treat them as 2 different categories. So this could be one example where the error analysis helps us also to understand the features of the model, or the researchers as well. So there are other instances, but it's not about the explainability of the models. And I have to say, we haven't started with explainability in legal NLP. We're going there we're starting something as a master thesis right now to how can you show a legal expert? You cannot show a legal expert a large language models as a function. And we talk about it. I mean, if you show the function to me as well, I wouldn't understand nothing. So you need some sort of simplifications and proxies to show, okay, the model might be deciding because of that, and it might have a meaning in a real world. So maybe in a real world, it would mean A, B, and C. And dear expert, if you see A, B, and C, what do you think? And the expert says, yeah, if I see A, B, and C, I'm sorry, your model is really wrong. So you have to fix something. But it's something we have to start with, yes.
How heavily are your models influenced by bias? I can imagine that although you have quite a huge data set, capturing law seems very difficult in all of its complexity and all of its kind of ways one could argument. Maybe you've seen some kind of arguments only very few times.
That's true, yeah.
Is this kind of a problem? Does this cause high bias?
So, okay, I think you have 2 points. So the first one is the sparsity of data. So you would see a type of argument very few times, and maybe there's other types which are much more common. And that's true. So this is the standard, what's the term? Like heavy tail distribution. So you have very many categories, but just a few of them are somehow, present in the data set, and most of them are just you see once or twice, or maybe not at all. And this is a general problem in any machine learning. Like if you do supervised machine learning, you have to tackle that. And there's ways to do so, subsampling and stuff like that. So we tried one of these techniques, but it was an issue, but it needs more investigation. Let's put it like that. Okay. So we don't have a solution for that. But the question with the bias is interesting because, we didn't actually see any bias here in terms of the actual data set from the European Court of Human Rights in terms of whether the models, of course you have, the cases are coming from different states. So it could be Germany versus Marvin, could be Czech Republic versus Ivan, could be some other, and there might be some sort of, priors or bias in the way people argue and stuff like that. But it's very hard, I guess, to disentangle in this setup. So you can maybe run some statistics. We didn't do that because we didn't have the resources. Let's put it like that, to be honest. Something to be explored, but also it's hard to measure. So when we talk in NLP, when we talk about bias in language models, so language models being ChatGPT, for example, we typically understand bias as this sort of maybe like gender bias or occupation bias, which means that the models are prompted to reflect the biases in the training data such that it used to be the case. I think it's fixed by now. But if you put like maybe the word doctor would be more associated with men, and maybe the word nurse would be associated more with women and other, so it's like occupational bias. and gender bias, and these are there. And there's methods on trying to debias language models through supervision. And we also had a paper with privacy and debiasing, trying to combine these two together. So the difficulty here is, well, not a difficulty. With these biases, gender biases and occupational biases, they are much easier to measure and create a data sets for where you can show there is a bias. While for the legal domain, it's so complex that, trying to measure how big the bias is without being super simplified, it's very hard. So we haven't tackled that yet for this reason.
If you are able to somehow get legal advice from this someday, so you have trained some model and it is able to give you legal advice on your problem.
Mm-hmm.
Have you considered how the model itself, in some sense, can legally assure its correctness?
Yes, I mean this exactly. So what you need is you would like to know. Okay, the model gives you, the entity gives you some sort of advice, and it's saying you do this and submit the contract here, and there's a notice. So, for example, let's say you have a contract with your health insurance. And if you want to quit that, you need some sort of paperwork, and there's some laws actually there are some laws governing that. So you would ask your model, okay, what should I do now? And the model will say, okay, here's the form, you need to fill it out and submit, and there's a deadline and stuff like that. And you want to say like, but why? Sorry, wait. I look at the insurance company website, and they say like you have to do you don't have to do anything. We'll care of that. So what's wrong? And then the model will say, okay, no, wait a second. Here's this law, basically in this, in the legal, in the book of laws. Here, this paragraph is saying, okay, this is this and this, and there's this 2 months notice, and because the case is similar. So basically explaining as a lawyer why it came to this conclusion, and that's what you need. So, and how to do that? Yeah, I mean, can you do that with sort of these large language models as we have right now, like GPT and ChatGPT? It's a tricky question because there are, I guess no. I mean, not in a reliable way. I mean, you cannot put any guarantees on what they produce, but because what these models are trying to produce is, it's very simple in a way. They're saying, well, I have seen some words. I have seen a sequence of words. So tell me what's the next possible or the most likely word coming afterwards. This is it. This is how they work. I mean, the context is very long. They have a lot of knowledge, but basically they're trying just to generate the next word. Through learning what the next word is, you have to learn quite a lot about the language, quite a lot about the world as well. So some sort of like factual knowledge and stuff like that. But there's no, as far as as far as I know, there's no like hard rules or explainability in terms of facts tied together exactly as we kind of would like to see. Like, oh, if there's this law, like rules, if there is this law, you need to do this, and if this is this, and this is this. So this sort of, I would say like symbolic or logical approach. So I guess, and people are saying that like combining these two would solve one of those problems, maybe. But I'm super speculating, and I'm not an expert on symbolic AI yet. So just take it with a grain of salt.
Now consider me an interested student. Which courses would you advise me to listen to get more familiar with your topic?
So you're a student coming and you want to study.
I'm a computer science student, and I want to get more familiar with natural language processing and your kind of field of research.
Oh, okay. Well, so if you're a student in Paderborn and you're interested in NLP, we just started this course, Natural Language Processing with Deep Learning, which is the crash course on contemporary natural language processing, and the toolbox we're using is deep learning. So you would learn both parts, like what is NLP, what's hard about it, and how to solve it. Well, not solve it, how to approach it with contemporary models like deep learning. This is a shameless plug. I mean, so because I'm teaching this course, so maybe next year more students will show up than this year because I just started. But if you're interested, just go. So you can watch this on YouTube. I mean, where I'm putting all the lectures and all the materials on YouTube and GitHub, and you can just have a sneak peek in there. To be honest, nowadays there's so many good courses online on this topic. So I'm pretty sure there's amazing courses on YouTube, which I'm not aware of, that once you accomplish them, you will get a great head start, depending on your background, obviously. You need some sort of programming. You might need a little bit of linguistics, but I'm sorry to say for the linguists here, you don't need that much linguistics for doing NLP nowadays. But you need a lot of software engineering skills and math and maybe statistics as well to get something done.
Are you also looking for student assistants?
Yes, absolutely. So again, shameless plugs. I mean, if you have some experience already with NLP and deep learning, then I'll be happy to have you in our team to join some research projects we're doing. Yes, absolutely. And what we're trying to do with student assistants is actually doing research. So it ends up like we're having a research paper together where the students also like co-authors of the paper if they do some substantial work in there. So I'm super happy to have junior people in the team doing some research work, because I guess it's important to showcase that research is creative. That's how I put it. It's hard, but it's creative. And as I said, plan A never works, plan B never works, but maybe plan C or D. And then that's where the fun starts.
I have one final question, and then you're done.
Okay, cool.
What do you do when you return to your work today?
What I'm going to do right now? Oh, okay. You don't wanna know. It's the role of assistant professor is very mundane task, like writing tons of emails, answering tons of emails, writing tons of reviews, chairing sessions and stuff like that. So research, it's very fortunate where I can focus on research and doing research. But when we do this, basically with this PhD students and postdoc in my lab. So when we discuss things and brainstorm things, and we already had a meeting today, so we discussed a couple of submissions and a couple of next steps. So I consider it as a research work. But most of the work we're doing is unfortunately kind of bureaucratic, I would say. But it's okay. It's fun. It's part of the job as well. And maybe I'll play some bass in the evening as well. I need to practice a little bit. So I'm gonna pick it up and practice again.
Sounds good. That was the All Day Research Podcast, the podcast of the Institute of Computer Science at the University of Paderborn. I'm Marvin Beckmann, and hopefully you will see or hear each other again the next time. See you then.
Thank you.
All Day Research Podcast. Dies ist ein Projekt in Zusammenarbeit des Instituts für Informatik unter der Leitung von Patricia Höfer und dem Fachschaftsrat Mathematik und Informatik der Universität Paderborn. Moderation und Redaktion Marvin Beckmann. Technik und Redaktion Yannick Greve. Sprecherin Sarah Akopian. Ihnen gefällt der All Day Research Podcast? Dann lassen Sie gerne eine Bewertung da.